This section is division of algebraic expressions. So we'll apply the rules of exponents when dividing algebraic expressions, and we'll also do it with long division. So we'll do it with rules, and then we'll do it for monomials, and then we'll do it with long division. So here's our properties of exponents rules, and so a couple of note here: a to the negative n, 1 over a to the n. 1 over a to the negative n is 1 over a to the n. In other words, this becomes, that goes up to the top, right? Becomes a to the n, if you simplify that. Okay. A to the m over a to the n. A to the m minus n, right? So we'll use those ones especially quite a bit here. But when you're dividing monomials, so one term over one term, like this first one, 3xy over ax, what you can do is just cancel your terms that apply with a similar variable. So x over x is 1. So this just ends up being 3y over a. So just cancel whatever's appropriate. Let's look at that second one, 10ab over 10a. Well, 10 over 10 is 1. A over a is 1. So this just simplifies to be b over 1. The third one, x over a to the x. The x's will cancel, and you're just left with 1 over a. Fourth one, negative 16a squared b over 4a. Negative 16 over 4 gives us negative 4, and then a over a cancels. I'm sorry, that's good grief. That's a squared over a. My apologies. See if I can erase that. There we go. Okay, there we go. Negative 16 over 4 is negative 4. Now a squared, I have two a's on the top and one on the bottom. In fact, let me write this out. I have a, and I have an a on the bottom, and I've got that b. So one of those a's cancels. So we're just left with negative 4ab. Let's look at that fifth one there. Negative 20 x to the third. So 1, 2, 3. 3 y's. I'll just write them out, and 3 z's. And we'll just see what we can cancel here. Negative 4 x and x, y, and 5 z's. And let's see what we can cancel here. I got negative 20 over negative 4. That gives us a positive 5. Then I have x on the top. 3 x's on the top, 2 on the bottom. So I'm left with 1x on the top. And then 3 y's on the top, 2 on the bottom. 3 y's on the top, 1 on the bottom. So I'm left with 2 y's. And then finally here we have 3 z's on the top, 5 on the bottom. So that leaves me with 2 z's on the bottom. All right, last one. We got negative 18 x cubed y over negative 12 x y to the fourth. So first of all, negative 18 over negative 12, that's positive. And they both go into 6. 18 divided by 6, 3. 12 divided by 6, 2. Now it has 3 x's on the top, 1 on the bottom, so I'm left with 2 on the top. And then I have 1 y on the top, 4 on the bottom, so I'm going to cancel the y, and I'll leave you 3 on the bottom. Okay? Any questions with dividing monomials? So here, second scenario here, we have 2 or more terms on the top. So look at this first one. I have x cubed plus x squared. I have a binomial on the top, 2 terms, but I'm still dividing by a monomial. Right? I just want to remind you guys, you know, if you're adding 1/3 and 2/3, that is 1 plus 2 over 3, right? Or in other words, a over 3 plus b over 3 is a plus b over 3. We're going to go this way now. So we're going to split it up. As long as you have one term on the bottom, you can split that up. So let's go ahead and do that. So this one would become x cubed over x plus x squared over x. Again, as long as you have one term on the bottom, a monomial, you can do this, right? So then we got x cubed over x, well that's x squared, plus x squared over x is just x. So we get x squared plus x there. Let's do this next one. Now we have a trinomial on the top, so I'm going to take each term divided by that common denominator, minus 2xy cubed over 2xy, plus xy over the 2xy. And now let's look at, I have x squared over x. That'll leave us with, well, first of all, 4 over 2 gives us 2, and then the x squared over x gives us 1x left on the top. I still have the y on the bottom. And then minus 2 over 2, so minus 1. And then x over x cancels. And then y cubed over y leaves me y squared. So minus y squared. Let's do this last one. Then we have x over x cancels. Y over y cancels. So I'm just left with 1/2. So 2x over y minus y squared plus 1/2 on that one. All right, last one here. This will become x cubed over negative x plus x squared over negative x minus 1 over negative x. Well, first thing I'm going to do here is, you know, if you have numbers, let's say you have 1 over negative 3, you just take that negative up top, negative 1/3, right? So let me take the negative up top, and then let me deal with x cubed over x. So it looks like I'm left with 2 x's on the top. Let's do the next one. 1 over negative 1, so I'm going to take that negative up top. X squared over x leaves me with 1x on the top. And negative 1 over negative 1x is a plus 1 over x. And we're all done there. Last situation necessitates I'm sorry, those are just my answers. Sorry, from the last slide. Long division. And so what we're going to do is, first let's look at doing long division. So when do you need to use long division? You need to use long division when you're dividing by more than one term. So for example, we're dividing by a binomial or a trinomial in the denominator. That's when you have to use long division. Okay. Well, it's very similar to when you're doing it with numbers. So let's go ahead and do this first one, 3475 divided by 3. So I put the 3475 as my dividend. 3 is my divisor. So here's my dividend. The 3 on the bottom is my divisor. And so what we'll get is we'll get our answer. We call that the quotient up top. And sometimes we have a remainder down here, right? And so we'll write our answer as quotient plus remainder over divisor, if you remember that. Okay, let's actually do it with the numbers. Just want to show you a little vocabulary there. So I go 3 goes into 3 one time. Now I'm going to multiply. 1 times 3 gives me 3. And I put it right there. And then I subtract that. 3 minus 3 is 0. So I got to bring down the next term, 4. 3 goes into 4 one time. And I multiply it. 1 times 3 is 3. And I subtract that. 4 minus 3 is 1. Bring down the next term, 17. 3 goes in 17 5 times. 5 times 3, 15. Subtract that. 17 minus 15 is 2. Bring down the 5. 3 goes into 25 8 times. 8 times 3, 24. There's my remainder of 1. So my answer is 1158 and plus 1/3. But we write it as a mixed number, 1158 and 1/3. But these and these are the same thing. All right? So we're going to do, that's how we're going to go about the long division with the polynomials. Okay, we're going to do that same thing. So what we do first is we go, I look at my 2x and I say, well, 2x goes into 6x to the 4th how many times? In other words, I gotta match that. What number will match that? And if you want, you can also go to the side and just to figure out the number, you can do that. And let's say you're right, it's 3. But how many x's do I need? 3x to the 3rd times 2x. So now I multiply 3x to the 3rd times 2x will give me 6x to the 4th. Okay, so I gotta match that term. And then, but I gotta multiply it by both terms, right? So again, how do you get this? So that's just 3x to the 3rd there. So what are we gonna do now? Well, I gotta multiply it through. 3x to the 3rd is actually times both of those. It's actually gotta go times both of those. So I've already written the first one, 6x to the 4th. So now let me write the second one. Sorry, let me get rid of some of these circles I don't want here. So I'm going 3x to the 3rd times both of those terms now. So multiply, multiply. So I've already written the 6x to the 4th. 3x to the 3rd times 7 is 21x to the 3rd. Now, just like with the numbers, we got to subtract this. So I'm subtracting the whole thing, subtracting both of those. So since I'm subtracting both of those, it's going to change both of their signs. So let me just do it this way. Since it's changing both signs, I'm going to do it like that. And now I do the subtraction. 6x to the 4th minus 6x to the 4th is gone. And that term should always cancel, or else you did something wrong. 15x to the 3rd minus 21x to the 3rd is negative 6x to the 3rd. And then I bring down the next term, minus 25x squared. Now I've got to match this number. So what times 2x gives me negative 6x to the 3rd. And by the way, when I did it with the first term, notice I put the x to the 3rd over the other x to the 3rd. So I matched it up there with the same degree. That just kind of helps me line this up so I know when I'm finished. So again, the question is, what times 2x gives me 6x cubed? Right? That's the question we're asking. What times 2x gives me 6x cubed? Again, Jose is right on that. Negative 3x. Now, I don't want the 3rd, because negative 3x to the 3rd would give me negative 6x to the 4th. I want negative 3x squared. It'll be 1 degree less. Oops. There we go. Squared. So negative 3x squared times 2x gives me negative 6x cubed. Negative 3x squared times 7 gives me negative 21x squared. And then don't forget, I got to change those signs because I'm subtracting the whole thing. Well, since I'm subtracting the whole thing, that'll change and that'll change. That'll cancel. Negative 6x cubed plus 6x cubed. Gone. So now I do negative 25x squared plus 21x squared, negative 4x squared. And I bring down the next term, minus 22x. And now I'm thinking to myself, okay, what times 2x gives me negative 4x squared? And again, if you're not sure, just go ahead and go to the side and do this. Negative 22x divided by 2x. Well, what does that give you? And I'm sorry, I totally wrote that wrong. This is, whoops. I meant, sorry, erase some of this. So what times 2x gives me negative 4x squared? Another way to do that is just think to yourself, take that negative 4x squared divided by 2x. And you get negative 2x. That's the key. That's the one you want. Negative 2x. So write that in, negative 2x. Now let's multiply it. Negative 2x times 2x is negative 4x squared. Negative 2x times 7. Negative 14x. Don't forget, we got to subtract this whole thing. In other words, both signs change. So change that sign, change that sign. That'll cancel. Negative 22x plus 14x is negative 8x. And I got to bring down the last term here, plus 21. So now the question is, what times 2x gives me negative 8x? Or, if you want to do it backwards, what does this give you? That's the giveaway. Negative 8x over 2x. In other words, I need a negative 4. Because negative 4 times 2x is negative 8x. So negative 4 times 2x gives me negative 8x. And negative 4 times 7 gives me negative 28. And don't forget, we got to change both signs. So that's gone. And now I see that my remainder is 21 plus 28. So my remainder is 49. So our answer is quotient plus remainder over divisor, just like with the numbers. So let's write it. 3x cubed minus 3x squared minus 2x minus 4 plus remainder was 49 over divisor, 2x plus 7. All right, let's go ahead and do a few more. Similar, here's our first one. Let's take 2x squared plus 5x minus 3. Let me erase some of this, it's not in our way. 2x squared plus 5x minus 3 and divided by 2x minus 1. Okay. All right, so the question is, what times 2x gives me 2x squared? And I say x it does. Oops, x. So now I'm going to go x times 2x gives me 2x squared. And x times negative 1 is negative 1x. And don't forget, we got to change both signs. So that's gone. And we have 5x plus 1x is 6x. And bring the next term down, minus 3. And now the question is, what times 2x gives me 6x? If you want to do it backwards, you go just do this, and it tells you the answer, 6x divided by 2x. In other words, it's 3, positive 3. So plus 3. And now let's multiply through. 3 times 2x is 6x. 3 times negative 1 is minus 3. And lastly, don't forget to change both signs. 6x minus 6x, gone. Negative 3 plus 3, gone. So I have no remainder. So this is my answer. It's just x plus 3. Just x plus 3. All right, let's do that next one. X cubed plus 3x squared minus 4x minus 12 divided by x plus 2. Let me get some room here. So x cubed plus 3x squared minus 4x minus 12 divided by x plus 2. Okay. So now we say, what times x gives me x cubed? Or another way to say that, what does this give you? X cubed divided by x gives us x squared. That's our answer. So x squared. Now let's multiply through. X squared times x gives us x cubed. X squared times 2 gives us 2x squared. And don't forget to change both signs. X cubed minus x cubed. Again, that first set of terms should always cancel or you did something wrong. 3x squared minus 2x squared gives us 1x squared. And bring down the next one. And now we're thinking, what times x gives me x squared? And what is it, you guys? What times x gives me x squared? Good. So thank you. Yep. Positive x. So let's go ahead and multiply through. X times x gives me x squared. X times 2 gives me 2x. And don't forget, change both signs. So now we got negative 4x minus 2x is negative 6x. And bring down the minus 12. And now we're asking, what times x gives us negative 6x? What times x gives us negative 6x? You guys say? Now let's try it. Let's say we throw in negative 3. Negative 3 times x is negative 3x. Uh-oh, I got to match it. So it can't be negative 3. So that's wrong. Let me try something else. Again, if you're not sure, good Valerie, if you're not sure, take the term and divide it by the x, and that'll tell you it's negative 6. You are correct, Valerie, very nice. So minus 6, multiply through, negative 6 times x, negative 6x. And by the way, I say that because these are so easy to screw up, you guys. You will mess them up, so just keep at it when you're doing it. Negative 6 times 2, negative 12. And don't forget, change both signs. Gone. And it looks like that's gone. I got no remainder again. So here's our answer. X squared plus x minus 6. We got 4y to the third plus 6y squared. Now notice there's no y term. It just goes to the plus 1. So what you do is you put a placeholder in. So I'm going to put in plus 0y. In other words, there's nothing there. And then the 1. So make sure you put in a placeholder if needed. The divisor does go down by degree here, 2y, and then the constant. Okay, so if you put that placeholder in, 0y, because there's no y term, that'll help you line this up real nicely. All right, so then the question is, what times 2y gives me 4y cubed? Here's the other way to ask that. right? What does that give you? So it's 2y squared. Now let's multiply through. And again, notice I put it over the same degree term, so I got to line this up. Now let's multiply it. 2y squared times 2y is 4y cubed. 2y squared times negative 1 is negative 2y squared. And don't forget, change the signs because you're subtracting that binomial. 6y squared plus 2y squared is 8y squared. Bring down the 0 term, 0y in this case. Now the question is, what times 2y gives us 8y squared? Again, this is asking the same thing. What's 8y squared divided by 2y? But I like to think about it as question mark times 2y gives me 8y squared. So we would have 4y here. So 4y. Now multiply through. 4y times 2y, 8y squared. 4y times negative 1, negative 4y. Don't forget to change both of those signs. So that'll cancel. I got 0y plus 4y is a 4y. And we'll bring down our plus 1. And now we're matching 2y. So the question is, what times 2y gives me 4y? What times 2y gives me 4y? You should say plus a 2. Yeah, good. I'll say it looks like typing. Yep. Plus a 2. 2 times 2y, 4y. 2 times negative 1, negative 2. Don't forget to change both signs. 1 plus 2 is 3. There's our remainder. So our answer is the quotient plus remainder over divisor. There's our full answer there. 2y squared plus 4y plus 2 plus 3 over 2y minus 1. So quotient plus remainder over divisor. Okay? All right, one more here. Let me erase. All right, looks like our dividend is c to the 4th. Now there's no c cubed term. And so I'm going to write it c to the 4th. There's no c cubed, but there is a 2c squared minus c plus 2. And this is all being divided by c squared, a trinomial. Minus c goes down by degree plus the constant. So I don't have to put any placeholders there. Now we're matching c to the 4th. So then the question is, what times c squared gives me c to the 4th? Or another way to ask that is, what's c 4th over c squared? So you should get an answer of c squared. You write it right there over the other squared term. Now I multiply through. C squared times c squared. C to the 4th. C squared times negative c. Negative c cubed. C squared times 1. 1c squared. Don't forget, you got to change all the signs. Gone. That should be gone. 0c cubed plus 1c cubed is a c cubed. 2c squared minus c squared is a 1c squared, and bring down another term, minus c. Now we're matching c cubed there. So then the question is, what times c squared gives me c cubed? You should say c. So now let's multiply through. C times c squared, c cubed, c times negative c squared, c times 1, 1c. Don't forget, you got to change these signs. Gone. C squared plus c squared, 2c squared. Negative c minus 2c. And bring down the plus 2. Now we're matching 2c squared. So it's what times c squared gives me 2c squared? You should say 2. Multiply through. 2 times c squared, 2c squared. 2 times negative c, negative 2c. And finally, 2 times 1 is a positive 2. And don't forget, you got to change those signs. Change, change, change. Gone. Negative 2c plus 2c gone. 2 minus 2 gone. So there's no remainder. So our answer is just the quotient. C squared plus c plus 2 is the answer here. All right. That's division with polynomials in a nutshell. Thanks for watching.